So the here we will see the calculus. In calculus we will deal with chapter differentiation. So fundamental theorem about calculus. We will study the fundamental theorem about calculus. Let u v w be the function of x. Let u v w be the function of x whose derivative exists d differentiation of coefficient of constant is 0. Means if you will differentiate a coefficient, the value of that will be 0. Suppose your differentiation of 2, your differentiation of 4, so it means to tell you that here differentiation of 2, here 4, differentiation of 4, here differentiation of 13, and here differentiation of 8, and so on. Means all the differentiation will be 0 because these are the constant terms and this is the k, so differentiation of this will be 0. Note here k is the constant. Let u v w be the function of x whose derivative exists. It means u v w is the function of the x, which means ux, vx, wx, and so on. That is, it can be also suppose that ux is 2x plus 3, ux is x square plus 5, and ux is x by 8, and ux is x square plus 4 by 8, and ux is x plus 3 whole square plus x cube, and so on. Similarly, v will be x square plus 4x plus 5, or v can be x minus 1 whole square, and so on. So such a kinds of the functions you will find. That will be the function of x. This will call the function of x. Note, if you the differentiation like this, then you will take common. Note, in such a kinds of the differentiation, here is a constant and here is a variable terms which is in terms of x. Means u is in terms of x. U is a function which is in terms of x, and k is a constant, just like 2, 3, 4, 5, 6, 7, 12, 12, 13, and so on. So take it out, and now the differentiation will be like this. This is a rule. So if the differentiation is like this in forms of additive or subtractive, means here u plus b and u minus b, if such a case will occur, then you will break them like this. Suppose that if there is a plus, means u plus b, then you will break ddx of u plus ddx of b, and if there is case minus, then you will break ddx of u minus ddx of b. So if the derivative, if the function is like this, means in multiplicative form, here u is a function of x and v is a function of x, so that can be written like this. Means firstly, one time you will take u as a constant, fill u as a constant, then take it as a out and write like this. Here v is a variable. Now plus, now this time take v as a common, this v as a common, and fill that by filling that this is a constant, so ddx of u, this will be ddx of u. So one time take a constant u as a constant, then write this and take v as a variable, and plus second, and one time take v as a constant and u as a variable like this. And when u and v are in division form, then take v as a constant and like this, minus take then u constant and like this by v square. Note here it does not mean that here v is constant and u is constant and here u is constant and v is constant. There is no, we are just filling it, that supposing that this is a constant and we are taking out, just supposing, it is not in a real. So when these are outside, So these are supposed to be a constant, not really constant. Similarly, if the function if the dy by dx is like this, then you can write as a 1 or like this. U and v is the function of x. It means ux and vx respectively, whose derivative is possible, means ddx of ux and ddx of vx can be done. Means ux and vx are not the constant terms, these are the variable terms in x. So suppose that ux may be, I am giving you example, suppose that ux is x square, and you put ux here x square, so ddx of x square is possible. That will be the 2x. I will show you in the next chapter how the differentiation is done. Similarly, the vx may be x square, x cubed plus 3 x plus 2 whole square, x by 5, and x plus x cube plus x power 4, and so on. There are so many types of the function that may be contained. So that's all about this. You are seeing the RSA study material. See more the video and increase your more knowledge. Just remove your unnecessary tension, and that's all about this. Thanks.